Hello, ladies and gentlemen. Today I want to talk about the one exception to the K.F.C. rule. Now, the K.F.C. rule is a strategy that we employ to help us solve multi-step, two-step, one-step equations easier, quickly, and efficiently. And it stands for constant fraction coefficient. This tells us the order in which we typically should eliminate numbers. Start with the constant, move to the fraction, then do the coefficient. But there is an exception to this rule. There is one type of problem that makes this rule void. And I'm going to show it to you here today. Take a look at this problem over here. Let's look at this equation. Find the constant, the fraction, and or the coefficient. The constant's right here, it's this -7. The fraction right here, it's the bottom of that 8 right there. And the coefficient would be right here next to the x. If I'm using the K.F.C. method, you would think, okay, we eliminate the 7 first, then we go and eliminate the 8, and that'll give me my x. But watch what happens when I do that. To eliminate this constant, I would have to add 7 to both sides, right? Add 7 to both sides. Cancel out, cancel out. I'll end up with x over 8 equals 5 plus 7, which is 12. I multiply both sides by 8 to get rid of the fraction, to eliminate the 8 in the fraction. I end up with x equals 8 times 12, which is 96. And you would think to yourself, yay, huzzah, that was really easy. Use the K.F.C. method, not a problem. Got a big number, but cool. Sometimes you get a big number, it happens. But try and plug that back into the problem and see if there is a problem. Okay, let's try it out. 96 minus 7 over 8. Does that equal 5? That's the question. Does this equal 5? Okay, well, 97 minus 6 is 89. Does that equal 5? Well, 89 divided by 8, that's like 11 and 1/8. Is that 5? No, it's not. So what went wrong? I did the K, I did the F. There was no C. I went K.F.C. I did it perfectly in order. What went wrong? This is where the exception is. Okay, so the exception to the K.F.C. rule happens when the constant is on top of the fraction line. When you have a fraction, everything on top of that fraction line, everything on top of this line becomes tied to the denominator. I like to think of the denominator as this big old bodyguard. And I can't really do anything with the top. I can't really mess addition and subtraction y with the top part of the fraction until I first take care of this bodyguard. So this is where the exception comes in. If the constant is on top of the fraction, then we have to use a different order. We have to get rid of the fraction first, and then we can go to take care of the constant and the coefficient. So this is the one time where we go out of the K.F.C. order. And instead, we're going to multiply both sides by 8 to get rid of the fraction first. Slice and dice. We end up with x minus 7 equals 5 times 8, which is 40. And then I'll add 7 to both sides. Add 7 to both sides. Slice and dice. And we end up with x equals 40 minus 7, or 40 plus 7, so 47. We end up with a completely different answer, almost half as big. Let's see if it works. 47 minus 7 over 8. Does that equal 5? Well, 47 minus 7 is 40. So I get 40 over 8. Does that equal 5? Yes, it does. And there we go. That's it. We found the solution. So what's the takeaway here? The K.F.C. rule works 9 times out of 10, but there is one exception. And if you can learn to spot that exception, you'll be just fine. The exception to the K.F.C. rule happens when the constant is on top of the fraction. When the constant is on top of the fraction, we eliminate the fraction first. So let's do a couple practice problems, just to be safe. I've got K.F.C., K, F, but no C. Looks like the constant is on top of the fraction. So I'm going to eliminate the fraction first in this scenario. I'll multiply both sides by 2. I ran out of room here. Slice and dice the 2's on the left-hand side. We end up with, let's put a little line here for some order. We end up with 3 plus x equals 12 times 2, 24. And then we'll just subtract this 3. It's a positive 3. I get rid of it by subtracting 3 from it. Slice and dice. I'll end up with x equals 21. And that's the right answer. Think about it. 3 plus 21 is 24. 24 divided by 2, does that equal 12? Yes, it does. So 21 works. If you're ever uncertain, plug it back in. See if your answer's right. You never have to be uncertain when solving expressions or equations because now you can just plug it in. Once again, K.F.C. No coefficient, but I've got a constant on top of a fraction. Since the constant's on top of the fraction, I'm going to get rid of the fraction first. It's the exception to the K.F.C. rule. Slice and dice. I'll end up with negative 3 plus x equals 2. Add the 3 to both sides. Slice and dice. I'll end up with x equals 5. Oh, no, it doesn't. I forgot to multiply 2 times 3. I was plugging it back in because I thought maybe that didn't feel right. 2 times 3 is 6. There we go. I forgot to multiply this side here. 3 plus 6 is 9. There we go. That one works. Plug it back in. That's exactly what Mr. Grapp did. He plugged it back in because he felt like, wait a minute, this doesn't feel right. He plugged it back in. Now let's plug this one in and see if this one works. Through negative 3 plus 9 over 2, does that equal 3? Well, yeah, it does. We end up getting 6 over 2, which is just 3. Awesome. Cool. Worked out. Good thing I checked my answer. Last one here. I've got a constant. I've got a fraction. I've got no coefficient. But the constant is on top of the fraction, so I'm actually going to go for the fraction first here. Multiply both sides by the denominator, 5. Slice and dice. I'll end up with x minus 9 equals 6 times 5, which is 30. And I'll need to get rid of this 9 here, so I'll add 9 to both sides. Slice dice. I'll end my equation with x equals 30 plus 9. 39. And you know what? Just for funsies, let's plug it in. 39 minus 9 over 5. Does this equal 6? Well, 39 minus 9, that's going to get me 30. And 30 over 5, 30 divided by 5, gets me 6. So yes, 6 equals 6. Boom. All right, ladies and gentlemen, that's the exception to the rule. Everything else works just fine, but if the constant is over the fraction, get rid of the fraction first, then the constant. All right, folks, that'll do it for this video. I'll see you in the next one.